Hey guys, CBHolo1 here. Welcome back to another video, and today we've got part 2 of this lovely blue comet here, where we're going to be trying to repair the mighty sounds of steam. So, I've been doing quite a lot of work off camera here, and it's really not been the smartest idea, because, as I said in part 1, I know this board doesn't work. At least I'm like 99% sure this board doesn't work. Doing further research, I have learned that these boards sometimes do work and are just incredibly quiet. So I did a bunch of testing, and I did some capacitance tests with my lovely fluke-meter here, and pretty much as far as I can tell, all of these capacitors, the big ones, are dead, like completely dead, and I'm pretty sure the small ones are also smoked. The transistors, I'm not sure. Tested, they seem to work fine. I'm going to assume that they do for right now. But it's led to a whole host of possibilities of ways that I can fix this. This is honestly probably one of the best condition Mighty Sounds of Steam board that I've seen, at least online. Which is saying something, because this board's in pretty rough shape. But what we're going to do is we're going to start running this engine, and we're going to actually test the board in its current configuration. So with that, let's get started. Alright, so first of all, noisy CW80. I'm not using my lavalier mic today, so you can actually hear the surroundings. But when I say a host of options of ways I can fix this. So, first option, do nothing. Great, done, cool. 2, I can replace the individual components on this board that have failed, either the capacitors or the transistors or both, depending on what I find to doing this video. That's the low-cost option. Parts are really not that expensive. I think like most of these capacitors are less than $1 each, and some of the smaller components are like 20 cents. It's crazy. Honestly, the most money I'd spend on it is in shipping, which is kind of sad, honestly. The third option is throw in the kitchen sink. All out, design a new board with new components that'll last forever, and get it manufactured by a reputable company, and have it sent to me. And then, in that case, I can post those designs online as well, so that other people have access to get their own brand new Mighty Sounds of Steam board, at least this specific one. There's a couple different variants, but I'm not going to go into that too much. So, because this is the one that I have, and I don't have one of the other variants on me to test out. So, first thing I want to do is I'm going to do a continuity test to make sure that this plug is actually receiving the signal from the center rail. There's a diagram that I found online that I'll put on screen now, that has a lovely depiction of how this board is put together. But obviously, for all of it to work, it needs a chuff signal from the locomotive. So if I've got no chuff signal, I've got no sounds. So I've got my meter here set to continuity. I can pop off my ends, and you can see we got sound. So what I'm going to do is I'm going to... Oh, hey, what do you know? I don't even need to turn the drivers. We got about 2 ohms of resistance from the center rail to the end of this plug. In the diagram that I have, they have a 220 ohm resistor in there, and what that's supposed to do is that's supposed to add background effects. It essentially just keeps this board constantly energized, and it makes like a quiet hiss in the background. And then when it chuffs, it shorts the resistor, sends a full current into the board here, and makes an actual chuff. So you get a steam idle sound and a chuff. I may experiment with that a little bit and add a 220 ohm resistor into the locomotive to make that effect, because that effect is honestly pretty neat. But I don't know. We gotta get this working first, and then we'll play around with it later. Another interesting fact about this board This board, as you can tell, doesn't have any sort of integrated chips on it. There's no logic or anything. It's honestly very simple. And I ran some simulations using a program called LT-Spice, which is a free program. I used it in school. That's how I learned how to use it. But I remade that entire circuit. I traced out this as well and confirmed that that diagram is correct and has all the correct values in the correct places. I couldn't find these transistors, which I think is going to be my Achilles heel of this entire project. These transistors are nowhere to be found online. As I mentioned, I think briefly in part 1. You can't find data sheets, nothing. So I'm guessing on newer transistors. And as I've done more research, contrary to what I said in part 1, there's a lot of different types of transistors, and they all do very different things. When I was running these simulations, I was playing around with different characteristics of these transistors, and it was making wildly different outputs. Now, that being said, when I was looking at those outputs, the outputs, I'll put one on screen here, are not, like, they're not smooth, but it's not the noise that you would expect to come out of a speaker. And I connected an audio output to the circuit just to see, in theory, what, sound it generates. And it is not anything remotely like what the mighty sounds of steam are. So with that in mind, I did a little bit more digging, and I found that this actually works on something called transistor junction Johnson noise. It probably also has something to do with the resistors as well. But basically, in real life, when you run electronics, you generate noise. Electronics are not perfect. Current, when it goes through them, will get mixed up and basically turbulent, if you're familiar with that term. And the current does this thing, and it makes noise and whatever. At least that's the best understanding that I have. And that noise is actually what generates the sound that we recognize as the mighty sounds of steam, chuff, and idle sounds. And then later the whistle, which the whistle's a little bit more complicated. There might be something else to that. I don't know. I haven't really dug into it too much. But because it's based on noise, which is a real-world phenomena, I guess, I can't simulate it. So I can get close. I can run a non-noise simulation, which is what the diagram I showed on screen was, or the output I showed on screen. But I can't fully duplicate what this will actually do. So I have to actually test it, which is where this thing comes in, but I'll get to that later. So for right now, I've done my simulations, which yielded nothing. Great. I know I'm not going to blow the board. That's about it. So now we just plug it in and see what happens. Okie dokie. Please do not explode. I really don't need that right now. My fiance went home for the week to go dog sit one of our friends' dogs, which means that if I seriously injure myself, similar to the incident that led to that, I have no one to drive me to the hospital. So, but I don't think there's enough energy in this board to result in anything like that. So, let's tempt fate and see what happens here. Well, holy cow. I can't believe that. That's wild. Two things. One, it works. Two, I just wasted like 3 days of doing simulations. Great, cool. I really wish I had a face cam so you guys could see my reaction when I powered this up and it made sound. It was just... What? So, I was thinking about it a little bit, and I have an answer for what happened. So, I was not lying. When I heard this board at first, it did not create sounds. Temporary pause. I'm going to unplug this thing because it's driving me nuts. Okay, I'm back. Yeah, so when I heard this board running on the club layout that I'm a part of, it was not making noise. So I figured that these capacitors were bad. Sure, go figure. So I ran capacitance tests on these. I used my meter and ran a farad check, basically, on all of farads are what you use to measure capacitors, by the way, on all of the capacitors on here. Some of them I got no reading at all. Some of them, like this guy, I was getting twice what the reading is saying. This guy was reading almost like 1,000 microfarads, which is insane. That shouldn't work. I guess maybe, like, I don't know, again, I'm not an electrical engineer, so I guess when these fail, they go to 0, but I had no basis for that. My only basis was the fact that I've now wasted my time and built this, which, by the way, this is the same circuit, just with different transistors and different capacitors. So now that I know that this works, I may plug this in just to see if this does the same thing. Just because I'm curious and I want to slightly validate the fact that I've wasted hours running tests. But hey, saves me money, saves me time. I don't have to actually fix the thing. I just, did all the simulations to make it easy. But whatever. Anyway, so when I tested those capacitors, they were reading the exact capacitance that you would expect. If it said 220 microfarads, it measured out at 220 microfarads. These didn't do that. So, I don't know. If you know electronics better than I do, let me know in the comments. If these fail, does it go to 0 farads or does it go to infinity? I'm genuinely not sure. Anyway, the reason this didn't work, despite, the components being the way that they are. As I said, this is in honestly the best shape that I have seen a Mighty Sounds of Steam board, at least any of the ones that are on the forums or shown online. And as you can see, it definitely has some wear. And by the way, when I ran my tests, I did scrape off all of this gunk on top to get a clean metal contact so that I wasn't, I wasn't getting zeros like wrongly, and I wasn't getting an increased like resistance or whatever. So I digress. This transistor right here, you can see there's a kink in the closest pin. When I got this and I took the shell off, this whole transistor was pushed off down to the side. Don't know how it happened or when it happened, but it was shorting out the base, and I believe this is the emitter, I think, or it's the collector, can't remember, but it was shorting it. So there's a diode basically in here, and it was just jumping that diode. So I was assuming that because that happened, if I just pulled it out and I tested it, this transistor was smoked. It was never going to work. I ran a diode check with my multimeter on this, and it did seem to be fine, but the readings were weird and inconsistent. So again, I assumed that this component was smoked and I was going to have to find another one. But I never tested it after I bent it back. I just bent it back, went, okay, it's probably broken. I'm going to go do research for 3 days and then make a video on it. So I did that, and you saw what happened. So I guess long story short, test your stuff before you assume that it's broken. Actually make sure that it is. But it's really neat that I now don't have to fix this, and this is all original components, original Mighty Sounds of Steam, and it still sounds great. It's really loud, which is not what I would have expected from what I was reading online. Most people have to adjust these capacitors anyway. They usually change out these 22 and 47 microfarad capacitors to 100 microfarad, and that beefs up the sound a little bit. Running my simulations, it is just one of the two of them. I can't remember which. But you only need to change out, I think it's, I want to say it's the 22 microfarad capacitor. If you swap this out for 100, it boosts the volume massively. So the simulations weren't all for naught. I learned fundamentals of how this worked. But yeah, so very interesting. This board, I honestly can't complain. I spent 3 days doing simulations, and in that time, I learned a ton about electronics, which is what this hobby's all about. I'm going to go on a little bit of a rant here. This hobby isn't so much about trains as much as it is education, at least for me. I'm not an electrical engineer, as I've said several times. I'm a mechanical engineer. Gears, drives, I get that. That I can do. I can design stuff. I can make things fit correctly so you don't have screws that require electrical tape on the side of the brushes to prevent them from shorting, or prevent the motor from shorting. But this stuff is completely foreign to me. So the last 3 days of just doing research on how capacitors work and transistors work, I had no idea what the heck a transistor was when I started this project, but now I do. I knew that they were in computers and they're basically just switches, but there's a lot more to it than that. And getting to learn all the details was honestly so much fun, and going down all of the rabbit holes was really neat. So that's why I love this hobby. It's the trains are cool, but the education that you get from it, I get to expand my engineering knowledge, and I get to work with friends. This is not my locomotive. This is a friend of mine's. So anyway, that out of the way, it works. Video is completely pointless. I'm going to go test this thing that I've worked on for 3 days and see if I'm going to blow my face off. All right. So before I go and test my breadboard that I made, I wanted to show you guys this. This is my LT Spice simulation of the Mighty Sounds of Steam circuit. As you can see, it looks very similar to the diagram that I showed you earlier, and the output is the output that I showed you earlier. If I wanted to make this the modified circuit, what I'm actually running on my breadboard, all I really have to do is switch this to a 220 microfarad capacitor, hit run, and you can see that the output just has a little bit more definition in these shark fins. Other than that, the only differences are a couple small changes in the resistances on some of these resistors, and they don't really have an impact on what the output, or the output that's coming through the speaker is. So as I was playing around with this, by the way, the individual pulses up here are a result of this clock switch. So this is meant to represent the contacts in the locomotive opening and closing. So what I have is a 60 hertz 15 volt AC input going into this switch, which is a voltage controlled switch, and that's connected to this pulse voltage, which is a DC 1 volt and 0 volt. It's on at 1 volt for a quarter of a second, and then it is off at 0 volts for 3/4 of a second, and that's what creates these pulses that you see here. But yeah, as I was adjusting values here, there really wasn't anything that made a huge difference in volume. So as I said earlier, if you change this 22 microfarad capacitor to a 100 microfarad capacitor, it should make it louder, according to the reports that I saw online, except it doesn't. So my simulation earlier, I guess, was flawed in a way, because what we're supposed to be seeing here is a change in this 720 millivolt and 800 millivolts. So this is sitting at about probably 775, we'll say, millivolts. That needs to increase in order to increase the sound. So say I follow the advice of all the people online and I change both capacitors out. Same thing. But you can see that between the 47 and the 100, there's no difference. So all of that change is as a result of this C3 at 100 microfarad being switched from 22. And when you get back to 22, it does this decaying thing again. So just thought that was interesting. My suspicion is that as people replace the boards, or replace the components, all they're doing is they're taking a capacitor that's failing and replacing it with a good capacitor, and that's what's causing the increase in sound. But I could be wrong about that. I'm not sure. Again, not an expert, not an electrical engineer. By the way, speaking of being an electrical engineer, if you are, or you have a good understanding of what circuits actually do, please help me understand what the heck this is. I don't know what's going on here. I just recreated it, and that was my only hope at trying to get any sort of data out of this. I don't understand circuits well enough to know what's happening here. I'm sure that there's an amplifier in here somewhere, and there's a bunch of other stuff that's just designed to create noise. But if you know, drop a comment. Let me know. I'd be really interested to know what in the world is going on here. So before I go and test the breadboard, I'm going to give you guys an audio sample of what the modified circuit sounds like and what the original circuit sounds like. So let's start with the original circuit. This is what the sounds, or the wave function that you're seeing here, sounds like. And here's what the modified circuit sounds like. Overall, pretty similar. Obviously, the modified circuit has a little bit more volume in it just because of the higher jagged ridges, but it's almost unnoticeable. So I'm not too worried about it, and it gives me enough confidence to hook up the circuit that I made and think that I'm not going to just destroy everything. But let's go see what happens. So I'd be lying to you guys if I said that I was in no way terrified about what's going to happen here. I have no clue. So let's find out, shall we? I feel like I should be wearing insulated gloves for this, because this is terrifying. I have always been deathly afraid of electronics. I know it doesn't seem like it, but I have such bad luck with anything digital that I'm just terrified that whatever I do is going to blow something up. And this is either going to confirm or deny that theory. So let's see what happens when I tap this. Oh, it buzzed. Nothing exploded. That's pretty neat. All right, I've got a little bit more confidence now. So interestingly, it is doing exactly what the simulation said it would. Starts out pretty dull, and then just gets quieter. I'm going to add a little bit more voltage here. Interesting. So, apparently, something about these particular transistors makes this circuit work. By the way, this is an 8 ohm, 1 watt speaker. It's the same speaker that's in here, except I think this is a 1/4 watt or a 1/2 watt. But yeah, so I survived. And I'm hoping you guys could hear the sound that this made. It basically just duplicated the sound that came out of the computer, which makes sense. It definitely had a little bit more gargle to it. Like it didn't sound as crisp as the simulation made it out, which, you know, tracks. That's the way that it should be. Again, real life, there's noise, but it sounded nothing like what this does. So I don't know. But either way, interesting experiment. And I'm alive to tell the tale. So, but yeah. If you guys are interested in recreating this circuit, apparently that's what it does. Alright, so now because I feel like I have to do something in this video, instead of yap my mouth, let's put the shell back on. This foam tape is usually completely disintegrated, so I am surprised and very happy that it is still intact. I'm also surprised by the fact that the lead goes to the back of the board. I don't know, maybe that was a limitation that they had at the time when they did it, but I feel like it would make more sense to put the pin that goes to your harness up front so that the wire is, you know, closer to the actual locomotive. Also, as I'm putting this on, I'm realizing that there's a way that this has to go. This likely has to go up and over, but that seems like it's barely going to reach. Maybe it's supposed to barely reach, and this is supposed to make the difference. I know what's fighting me. I'm just gonna elect to ignore it. Okay, I can no longer elect to ignore it. I just have to pull that back just a little bit. Oh, hey, what do you know? Board is still in place. Now I can thread these screws back in. Before you test it, of course. You're supposed to just screw in. Isn't that your purpose? No, it's because I don't have the hole lined up. There was a fourth option that I had thought of for this engine, if this board didn't work and I couldn't repair it, and that was to buy one of the early, well, I don't know if it's early, one of the rail sounds for sound tenders. I actually have one. I run it with my 2035 usually, but I'm not gutting that because my grandfather gave it to me. So, but if I had bought one of those and taken the electronics out of that and put them in here, if they fit, I could have had Rail Sounds 4 in this thing. But then it wouldn't be correct. Also, this is semi-scale, so I don't know if it's worth that kind of money. But then again, it's in a semi-scale tender, so like, what's the difference? I don't know. But that was the fourth option. It cost, there's one for sale right now. I think it's at $170 some for the tender. It's a lot of money for just a couple of electronics boards, especially when this one actually works. Now that the shell's back on, let's give it one last test. So you can see that it does not have the idle sounds. That's likely due to that resistor. I don't think I'm going to add it. It works as is. It's original. I think I'm just going to leave it. Obviously, if my friend wants the resistor in there, I'll put the resistor in. But this is the way that it came. This is the way that they're from the factory. This is the way that it's working right now. So I don't see any more reason to spend some more time on it. So there you have it. That was my repair of this Mighty Sounds of Steam board in this lovely blue Comet here. Overall, I'm sure a very underwhelming video because I didn't actually have to fix anything. It just worked, but I am blown away by the fact that it worked. And if this video was not entertaining, then hopefully it was educational. I definitely learned a lot through this project from basic electronics, like basic electrical components. And it also served as a bit of a refresher for me to learn how to make breadboards. And I got to learn about electrical simulations. So hopefully I got to pass on some of that knowledge to you. If you guys have questions, maybe I can answer them. Drop a comment below. If I got something wrong in this video, drop a comment below and yell at me and tell me I'm an idiot, because I probably am. Or if you guys just have comments in general about, you know, the Mighty Sounds of Steam or how pretty this engine is. Again, leave a comment. I'd love to hear them. Love to talk with you guys. It's great. It's a lot of fun. But yeah, with that, I hope you all enjoyed, and I am CW Hollow 1, and have a good day, or maybe good night in your case. See ya.